Hi, everyone. In previous video, you learned about the basics of charts and also how to apply color effectively. In today's video, we're looking at how to apply those principles. And specifically, we'll do learning by example. So we'll look at some of the charts that can be improved, and then we will look at how to improve them. So let's start. And some of the materials that you're going to see today is based on this book, The Guide to Information Graphics, The Do's and Don'ts of Presenting Data, Facts, and Figures. And it is by Donna Wong, who is the student of Edward Tufte. So this is probably second and one of the many times that you're going to hear the name Edward Tufte. So there are also other books that I would recommend. So they're all from Stephen Few. And now you see it, Information Dashboard Design and Show Me the Number. So those are really effective and compelling examples that you will find in those books that will guide you how to do effective design. So we'll first look at bar charts. And here we have two series of data. And we decided to use two different colors, red and green, to encode the different series. So there's an issue with using red and green. First of all, maybe a question for you is, what does this remind you of? So very likely is Christmas, right? Because red and green. And there's an issue with this is because a majority, or like a big majority of the population actually cannot see red and green. So red-green blindness is very common. So what I would recommend is using a color scheme, or stay away from the color scheme red and green, and instead use color schemes such as those based on gradation, such as using different shades of blue. Or if you do want to use different colors, then yellow and green actually show it really well, and most people can see them. And as we mentioned before, it's a good idea to use a website, Color Brewer, to find good color schemes that might be colorblind safe. The next example, we are looking at another data set. And here we've decided to use red to encode company profits. So what's the issue with it? So my intention of using red could be to highlight this chart. So actually, you will see quite a bit of charts that use red as highlight. But since our chart topic is company profits, so red is actually not a good design choice, because red often means something that is negative, something is not good. So if you have good things to say, such as company profits, actually using red is a bad idea. So instead, you would want to probably remove the color and then think very carefully about what are the things that you really want to highlight. Maybe, for example, only one of the bars you want to highlight. Then maybe in that one, you choose very carefully. Maybe use blue or green, which tends to mean a good thing. So as a joke, so probably the only time you might want to use all red is when your company is having losses. And in that case, you want to use red. But also in that case, you probably don't want to be working in that company anymore. So if you have this many losses. And also, when you're doing bar charts, we need to be careful about how we encode data by the length of the bars. So at a first glance, looking at this chart, you might see that probably nothing is really wrong about it. We're here showing the growth of company profits, let's say from 2004 to 2007. This is actually very similar to what you would often see in papers and reports and so on. But if you look very, very carefully at the vertical axis, you will notice that it starts at 75, and the maximum range is 100. So what that really means is that even though here you see a pretty dramatic growth from 2004 to 2007, actually the increases may not be as impressive as it sounds, right? So 2004 is at 80, 2007 is at 100. So it's only about a difference of 20. So what that means is that using a axis that is not really starting with 0 can give the false impression that something is a lot more impressive than it really is. So this is according to Edward Tufte's principle of do not lie when you are doing chart design. So for most bar charts, I would say almost always, the vertical axis should start with 0. So that means we should be truthful about how we do our design. When you're visualizing multiple series of data using bar charts, so often, as we mentioned, we may want to use different colors or different color gradation. So this is also an example that you will see often, and probably even the default of a lot of the charting software. They say, okay, I'm going to automatically assign a color or a color gradation for each of the series. So this is likely the default you're going to get. So what is the problem with this design? You might find that it's pretty disorienting. So as in, the first series is medium gray, and then lighter gray, and then black, and then white, and then darker gray. So as you may remember from the Gestalt psychology, people like to see things that are a lot smoother. So things that are going abrupt changes, high contrast, quite disturbing or disorienting. So a better design would actually be using gradation. So for example, same kind of data, but different color choices. So here we start with the lightest, and then slightly darker, darker, and then black eventually. So this is much more pleasing to the eyes and also easier to pick out the series. When working with bar charts, you will also need to think about labels. So labels as in the vertical axis label, horizontal axis label. And often when you're doing a vertical bar chart as shown here, the labels may be too long to fit them horizontally. And often the solution to resolve that problem is to rotate the label. So for example, here we tilt the labels in an angle so that we can actually show the full length. There's an issue with this, which is that by tilting the text, it makes the text a lot harder to read. And you may say, well, so that is the default. So what can we do about it? There's not really enough space. So this is a very good example to illustrate that often the default may not be the best design for your data. For example, bars can actually be horizontal, so you can use horizontal bar charts, so no one's stopping you from doing that. And in this case, it's even better in that by doing the bar charts in a horizontal layout, you can fit all the text very, very nicely. So that means the labels are very easy to read. And what that means is that do not settle for the default. So think about what are the small modifications you can do to make the chart much easier to read. In fact, you can get a lot of inspiration from everyday websites or news reports and so on. For example, this is a screenshot taken from Apple, where they're also showing bar charts. Right? So here they're looking at how the different interfaces speed are different. And they're doing the comparison. And you'll notice that they're actually using a bar chart here. But the bar chart is very well designed in that the data is encoded by length, and also the label is directly underneath, closest to the data. So in general, putting data or illustration or information closest to what you want to say, that is a very effective design. So take inspiration from what we see every day. So now we will switch gear a little bit to line charts. Right? So line chart is another very popular kind of charts that you will see. So this is a chart that someone may give you, and they may say, I already plotted the data, and even have given you the axes. So I label the vertical axes 0, 3, 6, 9, 12, and so on. And we're looking at some growth over some time, for example. So what's wrong with this? So can you improve this chart? So if you look closely, you will notice that the interval is every 3 units, so 0, 3, 6, and 9. So this is actually a little unnatural. So usually what people are more used to seeing is an interval of 5 or interval of 2. Right? So even though the previous chart was correct in that the data is correct, the axis label is a little unnatural. So given we have the flexibility of doing or changing that intervals or labels pretty easily, we should choose to pick the more common interval, like 2, 5, 10, and so on. And when designing line chart, we need to pay special care about how we are designing the range, as in the vertical range here. So if we set the range to be too high, that means the lines now become too flat. Then it can obscure the message we're going to convey. And similarly, if we set the range to be too narrow, where the lower point of your line and the higher point of the line is really touching the range completely, then we might exaggerate or overstate the trend that we want to capture in the data. So what that means is that we would want to aim for something that's not really going for the extreme. So a rule of thumb for designing line chart is to have the data or the data line to be roughly 2/3 of the range of the chart. So of course, this is a rule of thumb. So that means that there may be rules that we can break. But generally, this roughly 2/3 guideline is a very good starting point. Sometimes we need to visualize multiple line charts all together so that we can compare them. For example, for stock prices, it's actually quite common to see multiple stocks, and then we have all of them lined up. So how would you design that effectively, right? So a common default that you will see as shown on screen here is that the software would assign a pattern or like a mark for each of the line that you have. So maybe a dotted line, maybe like solid with circle, or maybe solid with hollow circles, and so on. So there's nothing really wrong or inaccurate about this representation. But again, if you may remember, what people would prefer to see often is things that are not as overwhelming. So how can we kind of calm people down when they look at this figure instead of overwhelming them with a lot of different patterns, a lot of different marks? So maybe you want to take a few seconds and think about what you could really do by applying some of the things that you have learned before. So have you thought about how to do that? So here's a good suggestion, which is that you may want to use a color. You may want to use a line thickness instead of using patterns and marks. So using the marks as in circle, triangle, and so on. So those are actually pretty hard to distinguish between when you're zooming out. So that means at a distance, circles look pretty much like rectangles or small triangles. And also, patterns are difficult to distinguish also. So for example, dotted line or versus like slightly more spaced out dots, they're actually very hard to distinguish between. So on the other hand, you may recall that thickness and length are really good, really fast for people to pick out the difference of. So using line thickness here is very effective. And then also you notice that we're doing double encoding. So double encoding as in not only line thickness, we're also using the brightness. So using both of them will ensure that when we do print this chart out, let's say in grayscale, everything will still show up very nicely. So this is a very good design alternative that is significantly better than the default, which is using marks and patterns. So sometimes you have a lot of lines that you want to compare, and it's not really possible to put all of them all at once in one chart. For example, in the previous design, it may be good for about 7 plus or minus lines, but if you have like 10s, 20s, or even 100 lines, then that's too much to fit. So what you can do then is to use what we call small multiples. It's a term coined by Edward Tufte. So small multiples meaning using a series or grid of small similar graphics. So usually using similar or the same range in the axes, horizontal axes and vertical axes, and putting all these charts in a grid so that they can be very easily compared. So in this case here, you will see that we have 6 charts here. So all the horizontal axes you can expect to have the same, let's say, same time range. And then all the vertical axes you can expect to have the same vertical range as well. So now we switch gear to tables. So tables is also very common, especially if you have a lot of numbers to represent and you want to show people the exact values, then tables is a great choice. So in this design, can you spot any problem with it? So notice that we are having a lot of things in bold, where there are only 4 numbers that are not in bold. So we can ignore the value 0, just assume there are some concrete values there. And having everything in bold is pretty problematic, right? So, or in other words, like making everything in bold, everything in italic. By doing that to emphasize things is actually not a good idea. So the main reason is because when you are making everything bold, everything italic, that also means you are actually de-emphasizing everything. So this is actually a very good quote from the movie, my favorite movies, The Incredibles. It says, when everyone's special, no one really is special. So applying that principle to charts, that means when you're making everything bold, everything italic, actually nothing really stands out. So think carefully before you apply these emphasis like bolding or italic. So this is a likely default that you will get when you are visualizing table of data. And meaning all the grid lines are turned on. And again, there's nothing really wrong about it in terms of accuracy. So you show all the numbers, you show all the row and column heading. But this is the scenario where error toughness would say that this is a very low data to ink ratio. So remember, data to ink ratio meaning how much ink, if you were to print this chart out, how much ink are you going to spend on printing the data? That means the numbers, the labels, and so on. And how much data are you going to spend on the grid lines, which may not be essential to interpreting the data. So in this case, we are doing a lot of printing for the grid line. So that means a lot of chart junks, right? So things that may not really matter. So how to improve this? So of course, first is to try and remove the grid lines. And then you gradually add the grid line spec, which will help you better interpret the data, such as using the grid lines to group the data, let's say, every 4 rows. So better organization. And also, you can use a background color to highlight the column that you want to emphasize. When you're representing data, we need to be careful about how we do alignment. Right? So here we're showing you 2 examples. And the one on the left, where we're doing left alignment and instead of right. And then on the right, we have numbers that have decimal points. And something you might notice is that the decimal digits, they are not really aligned. And also for column 3, company C, it actually doesn't have a decimal point. So not using the same number of decimal points or not having any digits after decimal point at all can be misleading. And because at a first glance, I may see that, whoa, the number for company A is much higher. It has 4 numbers, while for company C is much smaller. Right? So to help improve this, what we should do is to unify the number of decimal points that we want to use, and also to align them by decimal points. So it's much easier to glance at and to compare them. So as we mentioned before, pie charts, we should really use them rarely. But there may be times that we will be given some pie charts. So in those cases, then what can we do about them? Right? How do we be truthful in when we're using pie charts? So why do people like to use pie chart? So even Steve Jobs used it. So this is actually a screenshot from a much earlier presentation that he gave many years ago, where he's showing the market share of Apple product and then comparing to other competitors. So pie chart is a very popular choice for in marketing. And particularly in this scenario, where you may notice that the pie chart is not only, well, it's not only a pie chart, but it's also a tilted pie chart. So we mentioned that this is the kind of 2.5D chart that we exactly want to avoid. So why is that? So in this case, you notice that Apple is at the lower part of the chart, and the chart is tilted towards the audience. So what that means is that the Apple pie is actually appearing much larger than it would be because it's because of the perspective. So it's tilting towards the audience, right? So for that reason, in marketing, a lot of people like to use it because it can give the false illusion that a lot of things are kind of bigger than they are. So if you really do need to use pie charts, so please, so never use this kind of design. So something you notice here is that the sub-pies, I would say, not even add up to 100, so which is absolute no-no. So if you're really doing a pie chart, everything should add up to 100 or add up to 1. And possibly the only scenario I can imagine that it's a perfect use of pie chart is to show people how much of a pie that you've really eaten, how much you have not yet eaten yet. So this is the legitimate great use of pie. So when working with large amount of data, you will need to think not only about the design of the chart, but also the axes. And so far, we have only been looking about what we call linear scale. So meaning every single point, every single number, we're faithfully mapping that spatially to what people will see. But when you're working with large amount of data, you may be dealing with numbers in a wide range of orders of magnitude. So in that case, so how do we compress all these numbers and still make them all fit on the screen or on a piece of paper? So in those cases, then instead of linear scale, then you will want to use a log scale. So log scales will allow you to compress a wide range of data and then put them in a much more compact layout. So here's an example showing you how we apply a scale to both the vertical and the horizontal axes. So that means we're doing a log plot. So data that you are showing here is we call the file prevalence. So meaning how many times or how many machines that a file, let's say Microsoft Word.exe, would appear on. So for example, the point on the top left, right? So horizontal axis is file prevalence. So here we say a very low prevalence file. That means the file only appear on a few machines. So maybe this is a file that's pretty new, so only appearing on a few machines. And the vertical axis, we see, oh, they're actually close to 1 billion. To be exact, is 850 million such files. So here we highlight that in red. And notice that the range, the vertical range, is actually going from 1 to 1 billion, so extremely wide range. But because we're using log plot, so we're able to compress and still able to show that dot on the same screen. So the log scale is also great for compressing time as well. So here horizontally we're showing the chart in time, and we're compressing from 1 month, 3 months, all the way to 30 years. So that means in general, if we want to compress things and putting all the data in a chart, then using a log scale may be a good idea. So in this video, we'll look at how to fix common issues in bar charts, line charts, tables, and also we'll briefly discuss why we do not want to use pie charts.